Hello and welcome to week 50 of this 52-week series for the Web Pro on what every web administrator needs to know to be successful in this space. My name is Scott Forsyth, and today I am continuing on the Q&A, taking some questions that people have submitted here in the past, and just kind of going through. What I'm going to do is, if I take a look here at some of the questions, I'm kind of grouping today on two main topics, and one is DNS load balancing, and the other is CDN, Content Delivery Network. And so let's take a look here. The first is from Flussick. He says, "Hi Scott, I'd love to see two topics. Some clever DNS load balancing, not sure what capability Windows is offering, and also some end-to-end CDN redundant network setup, DNS load balancing, ARR nodes, and parent nodes, etc." And then also Adam asked a question down here as well. And he says, actually he suggests I should write a book on ARR. Hey, appreciate it. And actually I am writing a chapter, working on Professional IS 8 book, co-authoring that. And so as a matter of fact, I am writing a chapter on that. And he says, "For now, I would be interested in seeing a series on building an eCDN or an ECN using ARR and what are the best practices to scale it out geographically." And he says, "It seems that ARR is sold that way, really not sold, but at least talked about. I have tried to put my theory out and try it, but I just don't see the best way to route all my clients to these designated locations. Can you help with an awesome weblog? Maybe." So yeah, let's dive in. So what I want to do is let's talk about a DNS load balancing, and I want to look at some of the issues with the geolocation with DNS, and we're going to take a look at that. And then second, let's take a brief look at a CDN and using ARR to create and scale out your own CDN. Okay, so looking first at some clever DNS load balancing. Well, I'm not sure how clever DNS load balancing gets. So the first thing is DNS, one of the nicknames given to DNS load balancing is a poor man's load balancer. Because really DNS doesn't have the smarts that you're going to have with other kind of load balancers. In fact, the most granularity you have is really the IP address. That's layer 3. You don't even have anything from layer 4 on down. Nothing to do with ports, nothing to do with the client, any kind of configuration on their machine. And also DNS caches for a long period of time. You may say have a short time to live, like 1 minute, but not all DNS servers will honor that. And so you may try to make a change based on certain things and not have any luck. But let's take a quick look at the concept of DNS load balancing and how it would be set up. Okay, here's an example on an OrcsWeb server. So let's say we had like a contosa.com, and what we could do is we could have a host, let's say our root, and with an IP address of 1.1.1.1, it's just an example, and we would do a second one with 1.1.1.2. And the idea, notice that we have, and we could also do our W's for that too. So we do new alias, it would be www, and then that would point to contosa.com. So what we have now is we have our www and our non-www, and because we have two host records, it's going to balance approximately 50-50. And of course, we have some settings we can set on the actual record itself too, on how it balances between that. But again, I mentioned the issues we have is our caching, and also Microsoft DNS doesn't do anything special. There's no concept of health tests. If this server here was down 1.1.1.1, you would have no idea, nothing that's mentioned whatsoever. You can't really take it out of rotation automatically. So you could build your own. There are some products out there for DNS that does it. And actually Microsoft.com back in the day, and as far as I know, they still do it, although I'm not positive. And what they do is they actually do use DNS load balancing, and it has multiple IPs which will point to sub-server farms. And then those server farms, it's just assumed that every server farm is up, and it will distribute it that way. So if you want to distribute across data centers, you can consider it. But I would say DNS load balancing, it's the poor man's load balancer, and it wouldn't be a first choice that I would do in almost any situation I can think of, unless you're trying for major scale and you want to send some of the traffic to different data centers. Also, even just balancing and determining how much you're going to send to each one is very difficult to do as well. Okay, so let's segue to a second part regarding DNS and the geolocation. And how do we take DNS, determine where someone is located, and potentially point them to a different server? And Google does this. Let's actually go to Google here. And if we were to ping google.com with the current DNS server that I have set up, and notice that we get the 74, 125, 45, 139, and we're getting really fast response times from the data center here that we're hosting. So let's do something. Let's what we're going to do is if we were to take some free DNS servers, and let's point to a different one than what we have. And actually, that's just what I have right now. I had picked a random one. And so right here, let's try 8.8.8.8, which is Google's free DNS server. And so if we do an ipconfig flush DNS, and now let's ping google.com, notice we actually have a different IP that's given to us. Now, I guess it is possible that it is rotating through the 4 or so IPs that they give us. If we do this lookup and we do google.com, notice that they actually do give us a few we could potentially rotate through. But these are all 65 in the third octet. So see, it's a different one. And notice the time happens to be pretty well just as fast in this case, in terms of at least our ping times. But let's try yet another one. So let's do 4.2.2.1 and change that here. 4.2.2.1. And if we were to do flush DNS, and now let's ping google.com. Notice, okay, look at this. This is fascinating. We have a completely different IP again, and notice our ping times now are in the 20 milliseconds. So based on our DNS server, not the actual server itself, is the best that Google has available to them today to determine where we're located. Because our server makes a DNS request to our DNS server, and I've showed you 3 examples. Those are the ones that make the request to Google, and Google says, well, I know where you are, and therefore use this IP. So here's the issue you have. Let's say I now travel to Europe, but I continue to use the same DNS server. Well, Google is going to think that I'm still in the States based on the DNS server that I use, and I'm going to route all the way back to the States. And they can't tell for certain exactly where I'm located. So using DNS to determine your location, it is not possible yet today to do that well. Now, I know there's some changes being made in the DNS protocol, trying to update some of the DNS servers around the world. And over time, I think we're going to have some better solutions here where part of your IP information is passed through the chain to be able to do this. But that's not in place today. You can use DNS to find your geographical location, but it's never going to be proven at this point in time. And so it's a best effort is the best that you can take. Even Google, that works really hard to be able to address this, is not able to address that in a perfect way, as we saw here in this example. Okay, so all of this now brings us to the next topic that we have is a CDN. So first, let's take a look at what is a CDN, because many people know what it is, but many don't. And so a CDN, or a content distribution, or really a content delivery network, content distribution network is a potential name for it. And the idea is that you can front your website with some primarily for caching reasons. And so you can offload the servers, which are meant to do all the heavy lifting. Why should they also be serving up images and videos and fighting for the bandwidth? And certain pages can be cached. Why should we run them dynamically when we can actually cache them? Not only that, many CDNs are geolocated, so they're located around the world, and they can route people to the closest one possible. And so not everyone in the world is hitting the same location all the time. So that can be routed using DNS, or sometimes it can route by a redirect. So it hits the first server, determines where you're located, and redirect to a different, for example, a newyork.yourdomain.com kind of concept. Usually it happens behind the scenes as much as possible. So there are a lot of third-party options out there. Akamai, I think they claim to have, okay, here we go. Actually, right here, it says they serve about 20% of the world traffic, or the web traffic. And I think they claim to have 15 to 30% of the traffic, Akamai themselves say, which is incredible. And so they're serving up huge amounts of video that you watch. A lot of the downloads, I believe that the Apple updates use the Akamai servers. I know a lot of the Microsoft themselves rely on Akamai. Much of their traffic is fronted by Akamai. And there's a lot of big players spit out for many years. Akamai being the largest, Limelight. There's many different players in this. There's some free ones. Some telcos get into the CDNs. And then also a person-to-person type delivery. You see like BitTorrent is actually considered a CDN as well. Content delivery is really what it is. So there's a lot of options there. And I guess my first comment on this is I would say it'd be worth considering using some of these proven methods. These people are experts on it, And of course, you're paying for them, and there's certain things to consider, but they're going to do a good job. You choose the best one there that you can use. But Microsoft with ARR has provided the ability to create our own CDNs, which you can use for a corporate environment, for your own, whether you do it internally or a publicly hosted website. It is possible to create your own. And so let's spend some time and look at that today. So the really good article that I would say is this one here from Wanwu, and had written here, this is actually in version 1.0 of ARR, but it's actually improved in 2.0 and 2.5, focusing even very specifically on CDN related things. But the concepts are the same right from the version 1. And he's focused on this exact situation here. I'll include the URL in the notes, so you have access to that there. And so the concept here is you have what's called the edge cache or the child cache, two different names for the same thing, up at the front layer. And so the request will come in, and then this role here sometimes it can cache, and in this example it will do the caching. But this is also the layer where you would potentially do the routing based on the location, and you can do this with certain URL rewrite rules, which I won't show today, but in concept what would happen is you would say the request comes in, I can tell by your IP address where you're located, therefore I'm going to route you to a different DNS entry for what you'd have there. And then you have the parent nodes, and in this situation all this is a forwarder. It's kind of plain, it complements this role here, and it forwards to what's called the origin server. So if the request comes in to your front end node and the cache has the node, it's already been cached, then it's going to accept the request, it's going to serve it back very fast right to the end user. And you can actually have a concept ARR has called request consolidation. So if, let's say, you are serving up a huge video webcast, a series of some sort, it can take that request and says, hey, I just got 100 people requesting the exact same thing at the same time. Or I mean, you could be talking in the thousands. And so what we're going to do is we're going to wait until we get that from cache, and then we'll respond to everyone at the same time, rather than everyone nailing the server. And so it can really offload this origin server. You don't need a massive web farm, because instead you're going to be caching a lot of this stuff up front. And that's the concept there. And then you have a concept of what's called a primary cache and a secondary cache. The primary cache lives on each node. It's going to be faster. And then they also write through to the SAN to a secondary cache location. And so if these nodes don't find it in their primary cache, they look in the secondary cache. If they don't find the secondary cache, it's called cache miss, which means it doesn't have it available, and it looks it up through the parents, which can potentially cache here too, and can look it up in the origin server. And as you can imagine, you can distribute this too. So these can be smart enough to call it from different locations here around the world. It doesn't have to be the same ones, and you can have different sets, and they can point to different origin servers, or they can have a single origin server, but you could have different sets. So your environment, you can determine how you want to set this up. I'd really encourage you to go through this article in depth. So I do have a working example I set up. And so if we start with our child or the edge node, and the idea is we would set up a server farm, a real straightforward server farm. The list of servers that you would put is from the parent, that middle layer, and you would put multiple in here. For my simple example, I only have the one. And so now up at the server level, we would go to your application request routing cache. And here's where the caching rules are set up. And you would set multiple or one or more primary locations, and you would normally set up your secondary pointing to that SAN location. Give you better performance too, as I showed you in that diagram back there. So now there are a few other nice concepts here as well. You can pre-cache objects. So this allows you to point to a file where you can put a list of objects that you're always going to cache. And so that allows you to really focus on the pages that make a lot more sense to do that. You have the option to delete all the cached objects or specific cached objects. So if you want to just pick one particular URL and drop it from cache during any troubleshooting, you can do that. There's also some caching rules. So what you can do here is you can say either when no cache control directive exists, or in every situation, I want to cache or not cache for how many minutes. And you can put in a specific host name and URL. So it gives you a lot more flexibility, including wildcards, that you can do at this level here too. So this is supported. And we also have the ability to browse the cache configuration here. I have two examples that I had set up that I'll show you in a second. And we have OrcsWeb, for example, go into Files. You can navigate the structure here. And these ones here are actually cached. and they exist locally on disk based on whichever rules we had set. So it gives you a lot of flexibility to navigate that. And then the actual cache control configuration, you can enable how long you want to do it to clean up your percent thresholds, and also do you want compression to be set. So that's at the server level. And then also at the server farm level, we can set this up as well with some other additional settings here too. The duration, whether or not we use a disk cache, and here's the request consolidation I mentioned. And also, what do you do with the query string? And so do you cache, just you're going to have a lot more requests if you have unique query strings, but you need to be very careful you're not caching something that's really supposed to be unique for each one. So do you include or not, or completely ignore? So you have those choices. Okay, so then that gives us the settings for the caching. Then at the URL rewrite rule, I'm just showing an overview of some concepts. Then I would say go through those documents. They're going to show you this and a lot more than I can just show in a few minutes here. So what we do is we create a rewrite map, and we set the origin servers. I have two examples, and the idea is we would come in to something like orcsweb.mycdn.com, and that's where you would send the traffic. Now, some people will front this with a www.theirdomain.com if they want all the traffic to come here, and some will actually just send your images or your videos, for example, off to here. So you might have images.yourdomain.com, and then you would use a different URL for the backend. I've seen some people would use the www.theirdomain.com for the Akamai in this situation, and then in the new value they're going to put their non-www. So a lot of people don't realize it, and it's actually hitting whether or not you have that www is hitting Akamai or directly on the servers. There's different creative ways that you can decide as you research that. In this case, we have a URL for mycdn.com, which is made up, or you could use mycorporatecdn.com, and then that is really going to be calling all the content from orcsweb or fastnet.com, two sites that I'm associated with. So, and then the other thing that's set here is we have the default value with the set with a pound, and which is an invalid character. So if it doesn't match, we're going to get an invalid response back. And this is really important because we don't want this to be an open relay where people can use our caching servers for free. And so only what is specifically set in here. And you can see that this is very generic, and we can really set up a new customer with just this one entry, and then they're going to be set up. In this particular setting, obviously there's a lot more to do with being a CDN than what I'm showing you. And also, let me put a disqualifier too. I am no expert whatsoever on setting a CDN, even for a corporate environment, and let alone for any kind of distributed high-scale thing. It's not the world that I've spent time in. And so I'm sure there's many things that I will not be covering here today. But I'm hoping it at least gets the ideas, get you thinking in terms of what to consider here. So we have two rules. The one is at the front end, and if we come in here with the wildcard pattern, and if in the origin servers, that mapping that I just set up, in the HTTP host matches the pattern, then we're going to basically pass that through. And notice we have the track capture groups across conditions. What that does is then our C1 from here, we also say if that result is not a pound. So what we're going to say is only if it properly matches. Then we're also going to use that C1 again down here in the server variables. And we're going to replace, what we're doing is we're actually swapping out the HTTP host up here at the server variable level. So it was, let's say something like vastnet.mycdn.com, and we're going to replace that with www.fastnet.com. And that's what this trick is doing, is kind of swapping that out. And then what we're going to do is we're going to route it to our server farm. Now, here's the gotcha, or here's what's fascinating, is what it's doing is it's going to use the IP address of the server farm, even though we're swapping in the host header. So it's going to be www.vastnet.com, but it's not going to vastnet.com. It's actually going to the CDN master. It's going to your parent cache node level. Okay, so that is the core of the concept here. And then what we also want to do is anyone else that comes in, we need to make sure that this is a second rule that's set. Actually, back in that first rule at the bottom, we have stop processing the subsequent rule. So once it gets the first rule, it doesn't keep going, which means that anything that makes it past that first rule is not valid. And so we have a rule set which says everything, let's give them a 400 status, which is an invalid or a bad request. And so that way we ensure that no one can use the server for anything that they're not supposed to. It's really only handling the particular URLs that you've approved. So this is our child cache node. Now let's take a look at the parent cache node here. And so in the parent cache node, it's in this situation, in the walkthrough that I've done and followed there, Wanwoo's, it's actually very, very straightforward. And what we did here is at the top level in the application request routing cache and the server proxy settings, we turn this on to enable it to be a proxy. So it's going to proxy all the requests through. And you could tweak this further if you want to. And so then what we do is notice there's no server farm, although ARR is set up. And the requests, and even here, haven't even changed the bindings. It's listening on the default for all traffic. But you would make sure that this only receives requests from the edge cache node. And you're not going to receive any generic requests. Otherwise, you have an open proxy here as well, which you definitely don't want. And so now what we do is we have a URL rewrite rule, a real straightforward forward proxy here. And what we do is if it comes in, if it matches your HTTP host and we have a value, then we're going to and it always does, and we're going to rewrite to this rule here. So basically what this is doing now is it's taking whatever the request was. So let's say it's www.vastnet.com, and now it's resolving the real IP address and forwarding through. But this also allows us to have the caching set up at this level here too. So there's some caching that we would set up and ensure it's set up to the rules that make the most sense in this environment. So this gives us the 3 tiers. And actually, if we were to try it out, let's go here. And I'm going to go to vastnet.mycdn.com. And notice, even though I'm going to this URL, it's actually going through that CDN. So we've actually set up an end-to-end CDN. And everything here, notice, as long as the code here doesn't do any redirects, which it doesn't, it's maintaining this through the cache servers. And if I go back to my edge cache servers, and I can do it here, go into my monitoring, and it actually shows us the percentage that we're hitting. In this case, we have a 66% hit ratio in terms of what's calling from cache, which is pretty good. It'd be nice if we can get that higher, and if I did tweak that and refresh it a few times, I should be able to get up to about an 80-90% cache hit ratio. In this case, it says about a 13% bandwidth savings. So, I'd have to hit this a few times and with some images to be able to get those. There we go. You can see an example there. It jumped up quite a bit more. So this shows us some of the flexibility we have. Of course, I've only skimmed the surface. There's so much more to this, but it shows that Microsoft's ARR solution is focused on a CDN type situation where you cache up front and you can scale to multiple tiers, and you have a lot of flexibility as to how you would do that. And really, you could do it from geolocations. You could do that as well with some URL rewrite maps. It's possible to do that. And so give it a look if you're considering a CDN and setting it up yourself. Otherwise, there's a lot of services out there that have done the hard work already, and they've mastered, they understand different things that different browsers want to see and how to work with that. So thank you for tuning in. This is week 50. We have 2 more weeks for a 52-week series. And so I hope to see you again the next 2 weeks. I hope you have a great week. Thank you.